This module focuses on networker backup and recovery terms and various software components and their roles. Next, we discuss networker control data and licensing models. This lesson covers some common networker backup and recovery terminology. To understand the backup process, you need to understand the backup terminology associated with the networker product. These are some of the terms that we will review in the following slides. A save set is one or more files, directories, or file systems, or application-generated data residing on a networker client that is backed up as a unit to a networker storage node and written to a volume. The save set is defined by the path entered for backup. It is common to define multiple save sets on the same client. A save stream is a single save set in a process of being backed up or recovered. The save program runs on a networker client and is used to back up a save set. A volume is a physical piece of storage media, such as a magnetic tape or a file system directory to which backup data is written. A pool is a networker resource that represents a collection of networker-labeled volumes. Pools are configured with attributes that match save set characteristics, allowing the networker server to determine which set of volumes a save set should be written to during a backup. A group is a resource to which one or more clients are assigned. Groups specify the time of day that the set of clients start backing up, or, with probe-based groups, the time of day when probing occurs. With a probe-based group, the backup is triggered by successful execution of one or more user-identified client probes. A schedule is a networker resource that specifies the level of client backup to perform on any given day. This lesson covers the networker software components, roles, control data, The three primary types of networker hosts in a networker data zone are the networker server, storage nodes, and clients. A single networker server, along with its storage nodes and clients, forms a networker data zone within which data is protected. An enterprise may have more than one networker data zone. However, networker servers and storage nodes may belong to only one data zone. Networker clients may be backed up by multiple networker servers and therefore may belong to multiple data zones. Additionally, networker provides the ability to create multiple restricted data zones on a single networker server to support multi-tenancy requirements of organizations like IT service providers and cloud hosting providers. The most fundamental component of the networker software is the networker client. The networker client software contains all the functionality needed for communication with the networker data zone. Because of this, every host in a data zone must have the networker client software installed, including the networker server and storage nodes. The client's most important functions are to generate backups called save sets, push them to a networker storage node or device, and retrieve them during a recovery. While performing a backup, the client also generates tracking information, including the file and directory names in the backup and the time of the backup, and sends it to the server to facilitate point-in-time recoveries. Additionally, the client software will also contain graphical user interfaces or command line utilities that allow users to manually perform backup and recovery operations from the client. Networker storage nodes are dedicated hosts with directly attached or SAN/LAN accessible devices to support the storage of backup data. During a backup, a networker client sends backup data to a particular storage node based on the client's configuration. The storage node organizes the client's data and writes the client's data to one of its devices. Storage nodes also send tracking information about the save sets written to the volume during the backup to the networker server. The information is used for future backups as well as for recoveries. During a recovery, the client reads from the storage node. The storage node provides the device that contains the necessary volume. The networker server is always a storage node and is the default storage node for backups. A networker server can manage many storage nodes, but a networker storage node can be managed by only one networker server. In other words, a storage node cannot exist in two data zones at the same time. Storage node hosts have both the networker client and storage node software installed on them. The networker server is a physical or virtual machine that manages the data zone and facilitates client backups and recoveries. The networker server stores the configuration information for the data zone, including client configurations, devices, policies, and schedules in its resource database. Additionally, the server hosts the media database, responsible for tracking volume and save set location information. Finally, the networker server tracks the contents of all save sets backed up from all clients in its client file indexes. There can only be one networker server per data zone, and it must be available for any networker activity to be supported in that data zone. The networker server has the networker client, storage node, and server software installed and is configured to automatically back up its databases and client file indexes to ensure recoverability in the event of a disaster. Administration of the networker server is performed using the Networker Management Console Server, or NMC. It is a Java-based graphical user interface accessible from any supported web browser. The console server provides a global view of the networker environment, allowing you to centrally configure and manage one or more networker data zones, as well as run a number of pre-configured and customizable reports. The console server gathers information about backups from the data zone and can be hosted on the networker server or on a separate host. One Networker Management Console server can be used to manage multiple networker servers and data zones across an entire enterprise. Networker control data collectively represents the networker configuration information and the backup tracking information stored on the networker server. The resource database contains the configuration resource files. The media database is the networker database used to track the backups and the volumes they are stored on. Client file indexes, or CFIs, are the networker databases that track each file or path name in a client's backup, allowing clients to browse their backups for files from a particular point in time. The networker server creates and maintains one client file index per client. The networker server maintains resources are used to configure and define objects within a networker control data collective. Resources are used to configure and define objects within a networker environment. Each configurable component in networker is represented by a resource, and there can be multiple configurations for each type. Examples of resource types include clients, devices, tape libraries, backup start times, and policies. Nearly all networker resources are stored and managed in the networker server resource database. The networker server maintains tracking information for save sets and volumes in a client file index for each client and in the media database. The client file index, or CFI, stores the records for each backed up file from the networker client. There is one CFI per client host. The CFI information answers the question, which files were backed up and when, for each client. This information is used to support browsable recoveries, which allow clients to more easily recover files to a specific point in time. As the save sets age, the CFI records are deleted automatically to save space based on the defined retention policy. The media database is a SQLite database that tracks the networker labeled volumes and the save sets contained on them. This information answers the question, on which volumes are the save sets located? All volumes and save sets are listed in the media database and are needed to support recoveries. In the traditional networker licensing model, the networker server software is licensed per edition type in the operating system platform. The editions are business, workgroup, network, and power editions. As backup requirements grow and change, additional networker options may be purchased to tailor the backup environment to meet those changing demands. This slide shows the features provided with the base enablers and some of the additional features that are available. Workgroup Edition allows you to purchase an auto-changer license up to 32 slots. Power Edition and Network Edition support NDMP and cluster client connections, while Workgroup Edition does not. Support for a clustered networker server requires Power Edition. For Network and Power Editions, the maximum parallelism and the maximum number of device resources allowed are increased with each storage node license purchased. For the latest information on networker licensing, please see the release notes for the specific networker release and other networker provides an alternative licensing model based on capacity. With the capacity licensing model, networker software is licensed based on the source capacity metric. Source capacity is measured as the aggregate of full backups, measured in terabytes, from all data sources that are protected by the networker software, irrespective of where the data is moved. The source capacity license model allows for unlimited access and deployment of all networker features, modules, and options, and simplifies license management and maintenance renewals, since only source capacity of the data zone is tracked. The EMC AMP utility, a virtual appliance, is used to determine and track the backup environment's source capacity usage. This lesson discussed the primary components of the networker data protection solution and licensing models.